Good morning, everybody, or afternoon, depending on when you're watching this, maybe even evening, I guess. We're in Chapter 24, which is the urinary system. So the urinary system is one of our excretory systems. There are a lot of body systems that carry out excretion. So we have the integumentary system, which gets rid of urea, lactic acids, and other materials through sweating. We've talked about that last semester. We have the respiratory system, which we just finished talking about, which gets rid of carbon dioxide, which is a waste product of aerobic respiration. We will be talking about the digestive system next, after we're done with the urinary system. And that's one of our major excretory systems that gets rid of waste products that we have taken in, so the waste that wasn't able to be absorbed. But right now we're in our urinary system. So this system gets rid of nitrogenous wastes, drugs that are in our system, hormones, excess water to rinse everything out. So the urinary system is composed, this is just kind of a simple drawing, of kidneys, which are kidney bean shaped, ureters, which lead to the bladder, and then the urethra. And the urinary system, or the system, produces waste by filtering blood and getting rid of the materials that are not needed in our blood. So here are actual kidneys. Very beautiful. There you can see the long ureters coming out of each side. You see the bladder, which is right here. You don't see the urethra. The urethra is easy to draw in a diagram, but in reality, the urethra is not going to be easy to see. In a male, it's easier because the male urethra is much longer than the female urethra. So the kidney has multiple functions. One of those functions is filtration. We filter blood multiple times every day. We actually produce almost, so not quite, 200 liters of filtrate every day, about 180 liters to be more close. And if you remember, we have only about approximately 4 to 6 liters of blood. So we filter that blood multiple times, producing this filtrate. The majority of the filtrate is reabsorbed, though. The kidneys also function in the formation of calcitriol, which we talked about back in Chapter 6, because we produce calcitriol starting at the skin. The skin takes in UV radiation. Keratinocytes are going to then convert a pre-vitamin D, or produce a pre-vitamin D molecule, I shouldn't say convert, and then that's going to be sent to the liver, which is converted to another pre-vitamin D, which then is moved to the kidneys, and then calcitriol is formed. The kidneys also produce erythropoietin, which is a hormone that functions in red blood cell production. It produces renin, which helps in maintaining blood fluid balance, and it regulates acid-base balance, ion balance, as well as blood pressure. Oh, there's that. Okay. I knew it would be in there. I was like, where is it? Okay. So what does the kidney look like? Kidneys are kidney bean shaped. So this is a kidney that has been or has had a coronal section done. So this is the posterior aspect of the kidney. And it has this region here called the renal hilum. The renal hilum is the border where blood vessels, nerves, and the wow, I can't talk today. The ureter can moves in to the kidney. The kidney is located on the posterior of the abdominal wall. The right kidney is lower than the left kidney, and the reason for that is we have our big liver right here, and so the kidney sits right below that. The kidneys are considered retroperitoneal, which means they only have a peritoneal membrane, that serous membrane wrapping around all of your abdominal organs, on the anterior aspect, not on the posterior aspect. They are protected partially by our ribs, but they have other protections, specifically a lot of fat that surrounds them that helps to protect them even more. So kidneys have 4 basic tissue layers. They have a fibrous connective tissue wrapping that helps to, or that is, not helps to, that is attached directly to the kidney. It's the deepest layer. Helps to maintain the kidney shape, protects the kidney from any damage and pathogen entry. There are 2 layers of perinephric fat, and this provides cushioning to our kidneys. So any blows to the back by the kidneys, our kidneys will be protected. And then we have renal fascia. This anchors the kidneys to external structures, like to the back of the wall of the abdomen. Some renal anomalies. Renal agenesis is failure of a kidney to develop. So if it's unilateral renal agenesis, then typically it can go unnoticed. You might have a child that is born that way and you'll never know unless something happens to their kidney. Bilateral renal agenesis is fatal though. And so this is what renal agenesis looks like. If one kidney forms, the other one didn't. We have a pelvic kidney. This is when the kidney doesn't migrate up to the abdominal cavity, so it remains in the pelvic region. This can, and so I'll show you a picture, this can cause problems because the ureter is much shorter, and if the kidney, or if any pathogens get in to the urinary system, they have a shorter route to get to that kidney. Also, if it's in the pelvic region, when the bladder fills, that can put pressure on the kidney. If you're pregnant, that puts way more pressure on the kidneys. And so there's a lot more problems with pelvic kidneys. Horseshoe kidneys occur when you have a kidney that reaches from the right to the left side. So they're basically fused. Again, a horseshoe kidney doesn't always lead to kidney problems, but if you have a kidney infection on one kidney, it will travel very quickly to the other kidney, whereas normally a kidney infection in one kidney does not cause problems to the other kidney. Supernumerary kidney means that you have more than 2 kidneys. So you might have a 3rd kidney or a 4th kidney. Oftentimes this will go asymptomatic as well, just like the renal agenesis. But the 3rd or 4th kidney can cause problems. No, I won't say oftentimes. Sometimes the kidney can develop tumors, and that can be problematic. And in that case, you would have to have the kidney removed so that you didn't have to worry about that. The kidney has an outer structure and an inner structure. The outer structure of the kidney is called the renal cortex. So it surrounds this outer area, just like we talked about the adrenal glands, which sit on top of the kidneys. They had the adrenal cortex. Well, this is the renal cortex. And then the inner region is the renal medulla. So just like the adrenal glands again. Renal pyramids form. This is a renal pyramid right here. Here's another renal pyramid. Here's a renal pyramid. There's a renal pyramid. The renal pyramids are divided by a region called renal columns. So right here would be a renal column. Here's a renal column. Here's a renal column. And the renal columns are composed of the cortex dipping into the medulla. And so a renal lobe is one pyramid and the two columns that are next to it. The renal sinus is located over here where urine drains. Okay, we have a minor calyx here, another minor calyx, and then it drains into what we call a major calyx right here, and then the major calyxes drain into the renal pelvis, which drains into the ureter. So there's your renal pelvis right here. And here you can see the renal pelvis. We have minor calyxes here. This would be one of the major calyxes. You can see a major calyx there, a major calyx here, and then the renal pelvis, and then the ureter. Diagrams are always prettier, so you see the minor calyx, you have a minor calyx, the major calyx, and then the renal pelvis, and then the ureter. Okay. The nephron is the functional unit of a kidney. Each kidney has approximately 1 million nephrons. And so each nephron is what filters our blood. The nephron itself consists of a renal corpuscle, this region, and then the renal tubule, which is all this stuff outside of the corpuscle. So the renal corpuscle is where we have blood moving in. We have these little capillaries there. The capillaries are called the glomerulus, and then they're surrounded by this capsule. This capsule is called Bowman's capsule, or the renal capsule, whichever you like. And this is where filtration occurs. And then we have afferent and efferent blood vessels that come in. So blood moves in and blood moves out. And then we have the glomerular capsule, also known as Bowman's capsule, is a capsule where filtration of fluid occurs. Okay, it's impermeable, so tissue or so fluid is not going to be able to leak out of the capsule itself, but it does have permeable capillaries in it. The renal tubule then is composed of a proximal convoluted tubule, a nephron loop, this is also known as the loop of Henle, and a distal convoluted tubule. Hold on one moment. Actually, I'm going to stop this here, and I will start the next video on this slide, okay?